The formula, excellent. And the formula, of course, is x equals, do we have it memorized yet? You don't have to have it memorized. I'll always give it to you. But if you have it memorized, what is it? B squared plus or minus square root of.
No, it's negative.
I know. I'm waiting to see. Didn't take that long for people to hop in. But my computer's frozen anyway, so it's anticlimactic. It is not b, it's negative b plus or minus b squared minus 4ac over 2a, right? What part of this allows for there to be two answers? This part right here, right? Why? Because there's a square root, yes? And every time you have a square root, you have how many answers? One or two, right? So you actually never have one. What do you always have? Two, because it's positive or minus, right? Square root of 4 is what? Positive and negative 2. Square root of 9 is what? Positive and negative 3. So if this has a value under there, how many answers are you going to have? You can pull the blinds down, Julia. Or you could ask somebody nearby to pull the blinds down, like chivalrous Max. Well done, Max.
Wait, this one or like,
Well, that one, the one that's in their faces. There you go, buddy. Nice work. Whoa, watch out for the kitchen.
not bad.
That's good, buddy. Right there. Now, in 10 minutes, Navleen, when the sun is in your face, you too can lower the blind. Now, as I was saying, what would have to be happening down there to get two answers? Pardon me, Burke? Something would have to be square rooted there, yes? So any number. Any number that's what? What has to be under that square root sign for this to work? A positive number, right? So if this, frozen computer again, if that is greater than 0, is it 1, 2, or 3? Which is it? Some people are saying 1, some people are saying 2. Talk to your neighbor. Figure out which it is, because there's only one right answer. Ooh, I bought a new kind of coffee. It's quite delicious. I haven't had a sip of it yet. It's brand new. First pot today. And my Bubba mug keeps it so hot I can't have a sip. I poured that coffee at 6:15 in the morning. I can barely take a sip now. Because I have little baby mouth, Sarav. Spicy, no problem. Spice doesn't hurt me at all, but heat makes me cry like a baby.
So it's good if it's too hot?
No, I can't handle too hot.
Yeah. But how do you know if it's good or not?
Well, because I just finally had my first sip.
And how
It was delicious. It's still almost too hot to drink. Stupid in English, because we only have one word, right? Hot. It's spicy and it's heat. But in Spanish and every other language, there's two words. In Spanish, if something is hot, it's caliente. But if something is hot, it's picante. Spicy is picante, caliente is heat. I don't know what it is in French. Spicy is piquant, P-I-Q-U-A-N-T, right? And hot would be chaud. Oh, really? I know a French word that you don't, Max? You see how I'm not making fun of you about it? You always make fun of me when my bad French comes out. Always, right, Sarav? All right, come on. Why?
No, I don't want it.
Why?
Yeah.
Why is it greater than 0? Why will that get me 2 or 1? Which one is it? I haven't heard an answer yet. Does this situation apply to the red or the blue? It applies to the red. Why? Every positive number has how many square roots? 2. So if this is positive, then there's going to be 2 values, isn't there? Great. Now, that covers the red. That's number 2. But you can see I have 2 other options here. What happening under there would cause me to have no x values? A negative, because you can't square a negative number, can you? So if this is less than 0, I shouldn't do that in red. If that's less than 0, I'm going to have none, right? And what would cause me to have the blue? That's the tricky one. There you go. It's the only one I haven't done, right? If it's less than 0, then it's the green. Number 3, no roots. But if it equals 0, then it must be the blue, 1 root. Why? If this equals 0, what's the square root of 0? 0. And what's b plus or minus 0? Still b, isn't it? So there's only one answer, negative b over 2a. Everybody picking up what I'm putting down? Now, turn the page over, and you're going to see a new word. Everything that we just discussed is right there. But, ooh, that's nice. All black. Quality. Everything we just discussed has happened right there. If this, and I'm going to highlight, you don't have to. If it's less than 0, equals 0, or greater than 0, equals 0, or less than 0, yes? But now I'm going to give you a new word. The b squared minus 4ac is what we call the discriminant. Highlight that word, learn it, live it, love it. Because you're going to get test questions on this. It's not supposed to be crossed out, you piece of garbage. It's supposed to be highlighted. I'm going to give you a quiz and a test on this stuff. And on that quiz and the test, I'm going to say, use the discriminant to tell me how many roots this equation will have. And about 3/4 of you are going to say, you never taught us what a discriminant is. Because this is the 4th year I've taught this course. In the previous 3 years, every class did that. Even though I did this page with highlighting and recording, they said, you didn't teach us what discriminant is. We don't know what that word means. And then I went back to the video and I showed them and they were like, oh. Nobody said sorry, but that's okay. I got a thick skin. I can take it. So, there you go. Discriminant highlighted twice. So, the question becomes, if I want to know the nature of the roots, is that asking me for the roots? Or is it asking me what those roots will look like? It's asking me what the roots will look like. Nature of the roots means I want to know, are there 2 roots? Is there 1 root? Or is there no roots? Now, I want to take a second to explain something. Some textbooks, and this is technically true, they argue that 1 root is actually 2 equal roots. Because the line hits the x-axis, they will tell you it is 2 equal roots. But it looks, when you graph it, like there is only 1 root. I'm going to show you that in a moment when we use our graphing calculators. Everybody cool? So this one is a little bit tricky because we say 1 root, but it technically means two equal roots. And if two things are equal, how would they show up? There would only be one of them. Picking up what I'm putting down? Okay. So let's have a look at these, and let's use the discriminant to figure it out. Remember, the discriminant is just b squared minus 4ac. So in this first one, which I'm going to work in red, what would we punch in? 6 squared minus 4 times 9 times 1. And that would be 36 minus 36, which would be 0. My discriminant equals 0, so how many roots would I have? 1. This would be 1 root. And then we'll do b, which I'll work in blue. Well, it's supposed to be in blue, but it did a half line in red. We'll see what it does when it finishes. You guys go ahead and have a look at that. Oh, it stayed red. Lovely. B. What's weird about B? Look at it close. Is it a quadratic equation right now? And what about it don't you like? We'll start with that. If you don't know how to approach this, then answer my question. If you do know how to approach this, go ahead and continue to work it through. You don't like the fraction, right? What else about it don't we like? Is it quadratic? Why not, Jazz Carrot? Pardon me? Okay, it's not. It's all split up weirdly. That's another thing we don't like about it. And there's still one more thing I want to know about it. Why isn't it a quadratic equation? Because we cannot do the quadratic formula on this right now. There's no x squared. So let's deal with Luke's thing first. Luke doesn't, or no, let's deal with Jazz Carrot's thing first. He wants everything on the same side, so we have ABC, yes? Okay, so let's do that. 3x minus 4 over x minus 5 equals 0. Cool with that? Okay, now let's deal with Luke's thing. He doesn't like that fraction. How do I get rid of this divided by x? I multiply everything by x. So what's x times 3x? 3x squared minus 4 minus 5x equals, what's x times 0? 0. Does that take care of our square thing that Priyanka did? Excellent, it does. But is this in the right order? Is this ABC? No, why not? I need the linear term to be in the middle, don't I? To be b. So this is going to become 3x squared minus 5x minus 4 equals 0. Now can I apply the quadratic formula stuff? And do we care about the whole quadratic formula, Megan, or only part of it right now? Which part of it? The discriminant only. And the discriminant is b squared minus 4ac. So what is b squared? 5 squared minus 4 times 3 times, what kind of 4? Negative 4. So what's 5 squared? 25. What's negative 4 times 3? Negative 12 times negative 4? Positive 48. 25 and 48 is? Doesn't even matter. It's bigger than 0, isn't it? Right? So how many roots? 2 roots. Is everybody Gouda? Luke? Yeah, because we only care about the numbers. Because remember, the whole quadratic formula is actually x equals all those b, a's, and c's. So you can leave out the x because that's what you're finding. Now let me ask you this, guys. Can you do the quadratic equation if your the quadratic formula if your quadratic equation doesn't use x? So, for example, I gave you 3t squared plus 4t minus 7. Could you do the quadratic formula there? Yes. And t would be what you were finding. T is instead of X, so on a graph, where would T be? Would it be vertically or horizontally on the graph? T is the same as X, so where would it be on the graph? On the X-axis. This would be T. Everybody cool? Sweet. Okay, so let's look at that next question, and you can talk to your neighbor, because you may need to. Figure out that one. How are you going to find a value for P so there's no real roots? I'll wait a moment while you think about it. And 5, 4, a 3, a 2, a 1. And what do we got? Who's got an idea for me? Max.
He tried 9.
So you're going with guessing and checking, right?
Well, I wrote.
What'd you do? Yeah, tell me what you did.
So I just filled everything in. So quadratic equation is b squared minus 4ac. So
B squared minus 4ac. So you went to the discriminant because you knew you were dealing with roots.
Yes.
Excellent. Now, what'd you write in there?
So I put p squared because.
P squared because P is B.
Yeah.
Nice. Minus.
4.
I see that it went down. Just keep talking.
4, and then in brackets 1, and then in other brackets 25 because I'm just filling in.
Because everything's positive, yeah?
Yeah.
Excellent. And then what did you do?
So then I multiplied them all together and got p squared minus 100. And then so you're looking to get it equal to 0, you have to get something lower than
Well,
100.
we want no real roots, so we need that to be less than 0, yes? So P squared had to be less than 100. And then what did you do?
So I found the closest square.
Nice. So I agree. Perfect. When we get to there, we can do a grade 9 thing, though, can't we? We're going to square root both sides.
Yeah.
And we're going to get P has to be less than 10, right? Right? But there's a problem with that even. Because when we square root a number, how many roots do we get? 2, correct? So P had to be less than plus or minus 10, yes? Everyone agrees? Okay. So, what does that mean?
P is greater than 10, and P is less than positive.
So, Max said to try 9. And 9 will work because that's less than 10, yes? Will 8 work? Is 8 less than 10? Will 0 work? Is 0 less than 10? Will negative 1 work? Is negative 1 less than 10? Okay, we can go down all the way. Now, what happens at negative 10? If P is negative 10, then this becomes positive 100, doesn't it? So less than 10 is great. Here's my number line. There's 0. There's 10. I can't use 10, can I? So think back to grade 9. How would I put that on a graph? I can't use 10, so it's an open circle, yes? And we know that it's less than 10, agreed? But what happens when we get to negative 10? I can't use anything past negative 10, can I? Can I use negative 10? No. So that's got to be another open circle, doesn't it? So the right answers can only be in this space. Does everybody understand that? Remember how in grade 9 we taught you how to do this graph with inequalities? And then that was the end of the inequality unit, wasn't it? We never talked about why we had to do open and closed circles and things like that. Here we are 2 years later doing open and closed circles again. Everybody cool? Everybody good? Everybody understand why this works? Why I can't go past negative 10? Even though negative 11 is less than positive 10? Everybody understand why I can't use negative 11? Okay. This is what I am working with. Right, Jaskirat? Well, right here, yeah? So if I put 10 in there, that's 10 squared is 100. 100 minus 100 is not less than 0, is it? So I can't use 10 or anything bigger than 10, yes? You recognize that I have to be lower than 10, correct? You also recognize that negative 10 is lower than 10, isn't it? Which should mean if it was only lower than 10, I should be able to use negative 11, shouldn't I? Except, what is negative 11 squared? Positive 121. 121 minus 100 is not less than 0. That is why I can only have values in the middle here. Got it? Everybody got it? Yes, everyone is good? 100%? If you're lying, you're dying? All right, turn the page. And we're almost going to be done. So now, you guys have just seen how to do this. I want you to do this one right here. But I need 2 roots. So what do I know about the discriminant? Greater than 0, less than 0, or equal 0? Greater than 0. And then does anything else change? No. Go. So what are we doing this time? What's our discriminant? What's our discriminant? K squared minus
4
times
2
times. So k squared minus 24 has to be greater than 0, yes? Right? So k squared has to be greater than 24, yes? So k must be greater than what? Plus or minus root 24, right? Now, root 24 is essentially 5, right? Right? So I need to be greater than the root of 24, which for our purposes, we're going to say is 5. Well, whatever. Approximately 4.9. Everybody cool with that? So what would that look like on a number line? There's 0. Where's 4.9? To the right. There's 5. 4.9 is just before it, yes? Is 4.9 allowed? No. So it's going to be 4.9 with an open circle going up there, yes? That covers one of my roots. What's the other one? Negative 5, which would be negative 4.9. And then where does its line go? There's negative 5, so there'd be this open one here at 4.9, and it has to go that way. Is everybody cool? Because same thing you just asked about. Negative 5, when you square it, becomes positive 25. 25 minus 24 is 1, which is greater than 0. So I'm allowed to have negative 5 and everything on the other side of it. Everybody good? Going once. Going twice. Going thrice. Okay, You guys do these four while I hand around graphing calculators. Listen to me closely. Is everybody listening? These things cost about $100 each, which means sitting right there in that box is approximately $2,500. Okay? I'm going to lend them to you today free. From today onwards, if you do not have a graphing calculator like this for this unit, you don't need to have this model. You can have an old one like mine. But if you don't have one, I'm going to take your phone as collateral for one of those. I used to take shoes until students started walking out without their shoes. They would walk out of here with one shoe on and one off because you guys are so addicted to your phones that when I made it phones, ain't nobody left without it. Because you wouldn't dream of leaving this room without your phone, but leaving without your shoe, no problem. I'm kind of limping. I'm walking in circles. I don't know what the hell's going on. All right, I don't have one of my shoes. Where'd that go again? But when it's your phone, you don't even get past the door. I'm not complete. I don't have my mini-me. You laugh, Yoon, but it's true. You got a graphing calculator? You got one? Home doesn't do me any good. You need one? You're good. You're good. You need one, Josh? You're good. You guys back here? Do not leave with this. You need one? You got one? You need one? Good, good, good. Need one? Now, guys, if you don't want to buy one of these, but you want to do work at home, there's a couple of options. There's all kinds of graphing calculators online that you can use that work similar to this. Yeah? Okay. That work similarly to these. Okay? There is also, if you have an Android phone, you can go into the Google Play Store and you can get yourself a fake one of these and put it on your phone. It actually looks exactly like this, but on your phone. So if you want to do work at home and you want to use the actual calculator that we use in here, you go to the Google Play Store and you get the Wabbit Emu. And if you have an Android phone, you can get this calculator on your phone. Otherwise, of course, you can get graphing calculators. There's all kinds of them in the App Store. There's all kinds of them in Android as well. But in Android, you can get our actual calculator. But it's a little bit of a pain to install. If you can't figure it out, come and see me at lunch with your data on, and we'll get it installed for you. What? Which? The USB thing is a USB thing. The other thing is I/O, right? Input, output, power. So you can plug it into the wall. You don't need batteries. All right, everybody good? So listen to me, please. These you were supposed to be working on while I was talking, or while I was handing it out, but then I was talking the whole time. You weren't paying attention, because that's okay. You were paying attention to me. You guys go ahead and do those, and then we're going to we're going to go back, and we're going to use our graphing calculators. I'm going to teach you how to use them. Okay? So first of all, though, go ahead and use the discriminant on those. Everybody get what I got? Everyone's happy? Everyone can do this? That's B5 squared minus 4 times 1 times negative 3. 4 times negative 3 is 12. 25 plus 12, 37. Okay, yeah, you got to be careful with that. You look like you're peeing. All right, everybody cool? I could never pee there. Because all of you could see me. I can't pee when people are around.
In the kitchen?
Yeah, well, of course you would never pee in the kitchen. Although sometimes you see houses that have a little bathroom right beside the kitchen. Do any of you have that in your house? My parents' townhouse has the kitchen, and the downstairs bathroom is right at the kitchen. Which I don't like. I don't dig that. Huh? Because it's the bathroom, and it's right by the kitchen. Ew. You don't think that's a little good? I think it's a little good. That's just me, though. All right. Okay, everybody good? All right, now, I want for you to put down your pencils. There is nothing to write. Pick up your calculator because we're going to work with it. Turn your books back to the first page we worked on today, which was 88, I believe. Okay, guys, I cannot make my calculator any bigger than this. So, if you can't see it very well, I got some empty desks near the front. Just bring up your chair if you need to, because you don't need to write right now. You just need to work with your calculator. So if you cannot see the calculator that is up on the screen on your left, you need to be in such a place where you can. All right? I'll wait a moment if you need to move. If you do not need to move, we're going to go with how to fill this in. If you read this, you can see how to work it, right? So, we're going to start with this. Everybody should be looking at the blank screen on their calculator. Push the clear button so you're looking at a screen that looks like this with a cursor flashing in the corner. This will work on all versions of this calculator, whether you have the old one like this or the new one like what you guys have. Everybody's looking at a blank screen with the flashing cursor. Julia. Push clear. Nice job, Akshay. You are on fire today. God, Gummy Bear fixing calculators? What's next? All right. Everybody looking at this now, yes? Okay, now, in this top left-hand corner, you see a button that says Y equals. Push it. And then push clear. You should be looking at a line of Y's with equals. Is everybody looking at something that looks similar to that? It won't look exactly the same if you have a different calculator. You might not have these horizontal lines. Is everyone looking at this? If you have this horizontal line, it's okay. You don't have it, that's fine. It doesn't matter. I just said that. The horizontal lines don't matter. Some of you will have them, some of you won't. Everybody cool? All right, now. I'll just let this finish. You all done? Okay. Now, this first equation right here x squared minus 8x plus 16, yes? Previously to being able to use this calculator, you have not been able to enter a variable into your calculators, have you? Now you can. So, everybody look. See this button right here that says x, t, theta, n. Does everybody see that button? That button is your independent variable button. Whatever letter your independent variable has gotten, that's the button you hit. Do you understand? So, to punch this in, I'm going to push that button and, oh, look, I have an X. Does everybody have an X? Awesome. What is happening to X right there? It is being squared, yes? So we are going to push the X squared button, which is right there. And oh, look, X is now squared. Has everybody got an X squared on their calculator? Awesome. I couldn't be happier. Look at my beaming face. Is everybody cool there? Now, what is next? Minus. Stop. Am I doing subtraction or am I doing subtraction or am I doing negative? Subtraction. So I push subtract, then what? 8, then what? X. Then what? Plus 16. Is everybody looking at that? Excellent. Now, this is where it's going to get weird because everybody's calculators might have slightly different settings, but that's okay. Push graph. Everybody stop! Then you punch something in wrong. You didn't get that. Your calculator did exactly what you punched in. This is not like when you guys play video games. Oh my god, the controls and game doesn't like me. Because you have clocks on.
Find a loop here.
Stop. Only put your hand up if your screen does not look like mine right now. Only those people. All right. Now, what is probably wrong is what I'm about to fix. So, all of you now can do this. Push window. I lie. Push zoom. Then push 6. And that should give you this. All right, now, once again, push zoom so we can actually talk about it. Notice that zoom gives me all kinds of options. I can zoom in on my graph, out on my graph. I can do all kinds of things with my graph. Listen, please, you guys. For God's sake, shut your pie holes for 5 seconds so you can learn something about this. I'm going to let you play with the calculator in a minute. All right? I was quite pleasant about the first 10 times that every time you pushed a button, you needed to talk about it for 10 minutes. Now I am at the end of my patience. When you push 6, you set up a standard window on your calculator, which is 10 by 10. Okay? So when I push Z6, Z standard, you will notice that my calculator, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, made a standard window. Is everybody cool with that? The problem with that is, do numbers go higher than 10? Yes. Do numbers go lower than negative 10? Yes. So our calculator is smart enough, we can change this to any size we need by using that first button that we pushed, which was window. Is everybody, now that you have done Zoom 6, is there anybody who doesn't have this in front of them? Just one? That's a record.
The accent on here.
I have never, ever, ever seen that. Ever. You know when I've seen this?
Right.
Never. So I have no idea. Oh, yep, got it. Grid off. You want the grid on. No, not grid. Second format. We want grid off, coordinates on. Let's try that. Still close. Let's try that. Oh, axes on. Ta-da! Is everybody now looking at this? Going once. Going twice. Going thrice. Excellent. Now, I have asked you to do two things with your graphing calculator. One, I've asked you to sketch the graph, right? So, down at the bottom here, we're only going to do one from each section, okay? We're going to do 1A as soon as my computer allows me to write again. Okay, again, you guys don't need to write this down. Okay, I said no writing. This is being recorded, okay? Well, what happened, Ewan? It's the same thing that always happens. I have a piece of garbage technology that is supposed to be cutting edge. So I can't sketch it, so we're going to leave it just like that. Okay? Excellent. Now the next thing it says is I would like to identify the vertex. Now you guys are smart kids. The vertex of an angle is the corner, yes? So what do you think is the vertex of this shape we have drawn here? The bottom, the corner of it, yes? Okay, that's what the vertex is. So the vertex is right here. Now, look at this question. Read the question. The vertex is a maximum or a minimum appropriately. Is this spot a maximum or a minimum, do you think, for the values on that graph? You don't actually know. I'm asking you to use your brain. What do the words maximum and minimum mean?
The highest it can be.
The highest it can be means it's a maximum, and the lowest it can be means it's a minimum, yes? So is this point a maximum or a minimum? Which is it? Minimum, of course, because the graph is going up, yes? So we are going to use our calculators to describe the minimum. So here's what we are going to do. We are going to use, it says right here, the calculation function. Now if you look on your calculator, you see right there, C-A-L-C, calc. Third one over, yes? But it's a second function, isn't it? So I'm going to push second, except my calculator's turned off. Of course it's turned off. Second, calc. Now look at all the things your calculator will do for you. It will find values. A zero is the root. It will find minimums, maximums, intersects, and this is calculus. You don't need to worry about 6 and 7. We are only going to use 1, 2, 3, 4, and 5. Okay? What do we want? A minimum. So what button will we push? 3. And that should take you to this screen. And it should say left boundary on the bottom, yes? Now, this is where all of your video gaming skill is going to come into play. See how we've got direction buttons here? Use the direction buttons. And you will see, eventually, you will see as you push to the right, you will notice a cursor coming along. Does everybody see it? To the right. Because watch, Akshay. Watch these values right here as I push right. They're going up. Yes? And as I go up, my cursor is moving along the X value to the right. Does everybody see that? Everybody get your cursor showing approximately where mine is, around X equals 2.12. By pushing right. Does everybody have that? Okay, now notice the calculator is asking me the left boundary. It is saying to me, you want to find the minimum between two spots. So this is on the left of my vertex, yes? So that is my left boundary. I could use anything up to my vertex. Is everybody cool? So I'm going to push enter. And now what does the calculator ask? Right boundary. So where do you think I need to move my cursor now? To the right side of what? The vertex. So I'm going to use my arrow keys, and I'm going to move to the right side of the vertex. Once I have crossed over, have I crossed over? So I can push enter again. Now what does the calculator say? Guess. Why is it guessing? Because we don't know if X is going to have a perfect value, do we? We do because we did math, didn't we? We know that X equals 4 here, yes? Because we did this with algebra. But the calculator doesn't. The calculator assumes that this might be an irrational number. So it says guess. Do we want it to guess for us? Yes. So we push enter. What is our minimum? 4.00000. 4 and 3 millionths. Everybody with me? So the answer is 4. Does everybody understand? Can everybody do that? Sophie?
Does it matter where you plot the points on the left and right down?
No, as long as you're on the left side and the right side of the point you care about. If you're going to get a better answer if you get as close as possible. But you don't need to be. Good question. Is everybody cool? Okay, now I want you guys to try that for B. Go ahead and plug in B. So push y equals, clear off your first equation, and enter B, and try to make it work. 4x squared minus 12x plus 9. And try to make that work. Then we're going to go on and look at the other two cases. 4x squared minus 12x plus 9. Was everybody able to make that picture? Okay. Is it a minimum or a maximum? Minimum. So we would go second, calc, minimum, 3, and set up your boundaries. My cursor's on the left. My cursor is on the right. Guess. And I get 1.5. And when we look at the math that we actually did, we see that it was indeed 3/2, which is 1.5. Is everybody good? Yes? You're going to get lots of practice on this. Don't worry. Is everybody good? Okay. Now, please notice, I have also asked you to find the X and Y-intercepts. We're not going to do that today. We're just going to practice making the pictures. Everybody cool? All right. Try C. So go to graphing, clear it off, and enter C. 25x squared plus 10x. Was it plus 1 or minus 1? I can't remember. Plus 1. Graph. And notice it makes a really little skinny one. Is everybody good? Now, what have you noticed about all of these graphs? They've all been a curve, and they have bounced off the x-axis, haven't they? Which means they only touch the x-axis once, which is why we only have one root. Everybody good? Everyone's good? Okay, let's do number 2. Start with 2a. So let's punch it in. X squared plus 5x minus 14. X squared plus 5x minus 14. Graph. Now, what's weird? You can't see the minimum, can you? It has gone outside of our window, hasn't it? Does everybody see how we've lost the bottom of it? Okay, now watch. Remember I said we can change the window, yes? Everybody push the window button. Right now, our window goes from, on the x-axis, -10 to +10, and every tick is worth 1. Everybody cool? Everyone agree?
Yes.
And our y goes from -10 to +10, and every tick is worth 1. Everybody agree? Where do I need more space? Do I need more space up, down, left, or right? I need more space down, yes? So if I lower my y maximum, then I'll get more space downwards, won't I? So let's use our arrow keys to lower my y maximum to 5. Now the graph will only go up till 5. Do I need to drop the bottom? Do I need to go lower than -10? Yeah, because the graph went off the screen, yes? So let's drop our minimum to -50. Now what does that mean? Your graph is going to go from -50 up to +5. Everybody cool? Now, since our scale for y's is 1, that means I'm going to have how many lines going downwards on the y-axis? 50. That's a lot of little lines, isn't it? What if I change this scale to 5? Now how many little lines will I have going down? 10. Is everybody cool with manipulating the window? Let's check. Hit graph. Do we see the bottom now? Could we find our vertex? Is it a minimum or a maximum? Minimum. And then we would go to left boundary, right boundary, and find it. Is everybody cool? Yeah? Okay, let's try that. Second calc, it's a minimum, 3. And I need my left boundary, so my cursor, I got to get it over to the left. I'm left of my vertex, aren't I? Enter. Now I get it over to the right. Enter. Guess. Enter. And my vertex is at negative 2.5 on the x-axis. And notice it even gives me the y value. Negative 20.25. So this point on the graph is negative 2.5, comma, negative 20.25. Everybody good with that? Excellent. Now, I want to do something weird here. On B, I want you to make the 3 negative. So we are going to graph 2B as negative 3. If my computer ever thaws. Is it subtract 3 or is it negative 3? Negative 3. So I use the negative button. So negative 3x squared minus 8x plus 2. Graph. Now, notice what it did. It left my window in the window we just set. Can I see my whole graph? No. So the first thing is to try a regular window. Zoom 6. Can I see my whole graph? So we're happy now, yes? What's different about it? It's flipped over, so it has a maximum instead of a minimum, yes? What flipped it over? The negative 3. When the A was positive, it was what math teachers all call a happy parabola, because it looks like a smile. And then when A is negative, people tell you it's a sad parabola because it's negative and negative people are sad. How do I feel about stupid little stories like that? They make me want to take a ruler and shove it into my ear. Positive parabolas open in the positive direction, up. Negative parabolas open in the negative direction, down. If you need to hear happy parabolas and sad parabolas, please go find another math teacher. Because I don't like stories, okay? And when you take university level math, remember, your profs are all going to talk about happy and sad parabolas, aren't they? Because your profs aren't there to tell stories either. Now, how am I going to find that vertex? Second calc. Is it a maximum or minimum now? Maximum. So I'm pushing 4. Does anything else change? Of course not. Left boundary, right boundary, guess. Left boundary. Enter. Right boundary. Enter. Guess. And what is it? 1.3, 7.3. Negative 1 1/3, positive 7 1/3. That's where the dot will be. Can everybody graph? Awesome. Listen to me closely. You have your cumulative exam tomorrow. When you finish your cumulative exam, which won't take you the whole day, you are going to work on pages 90 to 91. You're just going to do those algebraically. And then we're going to go back to page 88. Hopefully we'll have time. And we're going to work on finding the X and Y-intercepts with our calculators. Damn, I needed 10 more seconds and I would have ended right when the bell rang. Would have been that close. Almost perfect. Don't leave with one of my calculators. If you need a calculator tomorrow, Make sure you bring your phone to drop it in that bin. She'll walk by here in a moment. You didn't take one? You didn't? No, you did. You too, Mr. Mod. I know, I saw you walk up. You have your own.
I can take one.
You have your own. See him. You have your own, you have your own, you have your own. You put one in already. You are putting one in now. You are putting one in now. You are putting one in now. You have your own? Yes, you have a fancy one. You put it in already. Hey, man. Carlin.